Hello and welcome to our presentation on grounded video situation recognition. I'm Zeeshan and this work is done with CV Jawahar and Makarand Tapaswi at IIIT Hyderabad. Video is a complex modality consisting of multiple events, complex actions, humans, objects, other entities, and their interactions densely entangled over time. Prior works in video understanding have tried to address several subproblems like action recognition, spatiotemporal grounding, question answering, and captioning. While important, each problem only partially addresses the underlying dense semantics and provides limited understanding. On the other hand, holistic understanding of videos require understanding multiple events and answering questions such as who is doing what to whom, with what, how, why, and where, considering the full temporal context. In this work, we address the challenging task through situation recognition. Video situation recognition through semantic role labeling is recently proposed by Sadhu and others. It is a structured prediction task over 5 short clips consisting of 3 subproblems. First, recognizing the salient action verbs and the clips. Second, predicting roles that are associated with the verbs and the corresponding entities that are part of the action. And third, modeling simple event relations, such as enable or cause. For example, in event 2, the verb is talk, which is associated with 4 roles: talker, listener, manner of talking, and scene of the event. While the task is an important step towards holistic video understanding, it has its own challenges. The roles are annotated using free-form text captions, which makes them challenging to model for several reasons. First, the word distribution is extremely long-tailed. Second, the scenes are complex with the presence of rare concepts such as shield, boulder, and trident that are difficult to capture. And third, captions are ambiguous, which means an entity can be represented with different words. For example, women with shield and women with black hair are both correct references to the same person. Moreover, due to the ambiguity in captions, it becomes difficult to evaluate the model, since a model that generates a correct but syntactically different caption would be penalized. This figure represents the long-tail distribution of words for different roles in the BitC2 dataset, with words like man occurring 26k times in the verbs agent or argument 0 role, while officer occurring only 300 times. To remove biases of the captioning module and gauge the model's ability to identify the roles, we propose grounded video situation recognition, GVSR. In addition to predicting the captions for the role entity pairs, we now expect the structured output to contain spatio-temporal localization of the roles. Unlike previous works that models the task separately, we enable joint prediction of 3 tasks. First, verb classification. Second, semantic role labeling. And third, grounded SRL for end-to-end situation recognition. Since bounding box annotations in video frames are expensive and limits the scalability, we choose the weekly supervised route, where supervision comes from captions and don't need ground truth bounding boxes during training. Given the hierarchical nature of the GVSR task, we propose Video Whisperer, a 3-stage transformer model for end-to-end prediction of first verbs, second localization of roles, and third captions for roles. In order to capture rare and fine-grained entities and actions, we use video object encoder to contextualize both the object and video features along the full length of the video and predicts both verbs and roles. Then a role object decoder is used to search and localize the role entities for each role query. The cross-attention between role query and objects is used to predict the grounding for each role. Next, the role entities are fed to a caption decoder to generate captions for every role. All the predictions across the clips are generated in a single forward pass. We achieved state-of-the-art performance in the task of semantic role labeling with a 22-point gain in CIRA score over VITC2 and an 8% gain over a recent method which uses far better features. Moreover, we enable spatio-temporal grounding of roles, which was not supported by the previous works. We also enable end-to-end situation recognition and achieve comparable performance on the verb prediction task and state-of-the-art results in semantic role labeling. Now we look into some qualitative results. Here is a 10-second video from a movie scene. The entire video is fed to a video whisperer at once. And this is the event-wise structured prediction from the model. As can be seen, the model is able to predict correct actions such as walk and open. It also generates correct captions such as woman in white dress. At the same time, grounding it in the respective clip. The model is also able to ground the difficult non-visual roles. For example, in event 3, argument 2, that is, to get to the door, the model grounds the woman's arm in frame 3 correctly. Thank you for listening. Please refer to our project page to read our paper or for further details on code or data.